Welcome to Riju and PSK online classes. See, these days classes are getting a bit longer because the portions are like that. I can't cut in between. So, I want to finish certain section and it goes a little beyond. You can just fast forward and see my class, no problem. You can increase the speed. Okay, put that as 1.5x, then I think it will be okay. Now, last class we studied about a meter bridge, and we know that meter bridge is an application of Wheatstone's bridge. The working principle of Wheatstone bridge, it works on the principle of Wheatstone bridge, and this is used to find resistance, and it uses null deflection, and there is a high resistance here, high resistance. Why is a high resistance required? It is to protect the galvanometer from burning out. If this resistance is not used, there is a possibility of a galvanometer burning due to high current. To prevent high current, we use a resistance here. Fine. Now, this is the practical thing, and I told you that the construction 1 meter long wire, everything I said, the balancing length, then we derived the condition or the unknown resistance is SL into L by 100 minus L. I proved that, and using meter bridge you can determine specific resistance, because you are given a wire, you measure the length of the wire, area of the cross section, then you can use meter bridge to find the resistance. From resistance you can find out resistivity using this method. Fine. Now, if you do this experiment at two different temperatures, for the same wire you will get two resistances R1 and R2. Then if you know the temperatures, you can find out the coefficient of thermal resistance. Fine. So, that can also be done. Now, some theory questions. Why are connections between resistors in a Wheatstone or meter bridge made of thick copper strips? I told you, thick copper strips, and these are used to minimize resistance of the connection which are not accounted in the formula. When you make wire connections, there will be some extra resistance. This should be minimum to get correct answer. That is why we use copper strips, thick copper strips and screws. Second one, there will be end errors, like the measurement will have some errors. To minimize error, the balancing length must be preferably at the midpoint. So, the wire is 100 centimeter long, you should take the balancing length at the center. So, these are the two questions that can be generally asked in theory examinations. Now, let us do one numerical. Shown in figure below is a meter bridge setup with a null deflection in the galvanometer. The value of the unknown resistance is. See this thing. This is the standard resistance, this is the unknown resistance, and the galvanometer balances here at 20 centimeter. Normally meter bridge has got 100 centimeter wire. Okay. So, if one side is 20 centimeter, what is the other side? This should be 80 centimeter. Okay. Now, which side is P, which side is Q? That is very important. Which side is P? You should take you should actually not worry. You have 55 ohm here, R ohm here. The standard equation for the resistance R was S into L by 100 minus L. S into L by 100 minus L. But be careful that the length L, the balancing length L must be from the unknown side. The balancing length must be from the unknown side of the resistor. Fine. So, the best way to answer this thing. So, I said in the normal meter bridge connection, you have one resistor, we call it as R, and there is the standard resistance S. Then you have the standard resistance wire AB. Then there is this battery connection. This is what we normally do, and your galvanometer will be connected here, and this is the point where the jockey makes contact with the wire. This is called L, this is called 100 minus L. Okay, so from where do you measure the balancing length? From the unknown side. The length from the unknown side is always measured. That is how you use this equation. But here purposely they have given R on this side and 20 here. So, you can't take balancing length is not 20, balancing length is 80 centimeter, it will be from the unknown side. So, you should make this is L and this is 100 minus L. So, what is the resistance R here? That is the standard resistance is 55 into L should be equal to 80 and 100 minus L should be equal to 20. So that is 4 times 55 and that must be equal to 220 ohm. Don't get cheated with the equation. I'll tell you an easy method to do this. It's very simple. No need to worry about all these details. 55 by this length equal to R by this length. That's it. 55 by 20 is equal to R by 80. That's simple, direct. Resistance on the left side by length on the left side. Resistance on the right side by length on the right side. That will give you equation. So what is R? R is 220. Okay. But don't directly use this one. Do not take L to be 20 and 100 minus L to be 80. Your answer will go wrong. And I think that option also is available there. Okay. Now, this is a question from your NCERT. Okay. A meter bridge, the point D is a neutral point. Point D is a neutral point. The point D here means you are touching the wire and that is the balancing point. It's called neutral point. The meter bridge can have no other neutral point for this set of resistances. When jockey contacts a point on meter wire left of D, current flows to B from the wire. When the jockey contacts a point on the meter wire to the right of D, current flows from B to the wire through the galvanometer. When R is increased, the neutral point shifts to the left. This question from exemplar. Try to work out this one, try to understand what is happening in the circuit. Definitely when we do MCQs, we will study more questions on meter bridge and that ideas will become more clear. Okay. So today after this meter bridge thing, we are going to discuss about some other device. It's called potentiometer. So we will go to potentiometer right now. Potentiometer is a very confusing item for +2 students generally. Even last year I remember while board exam approached, students started asking, sir, can you teach potentiometer again, can you explain it? We are not able to solve questions on that one. In fact, potentiometer is a very simple thing if you have proper logic, but the circuit and the theory is really complex. Let me take potentiometer the way you have to write for your board examination. After that, I will tell you what is actually happening in that one. Fine. Okay. So, question number 1, what is a potentiometer? Answer, it is a device which is used to measure EMF of a cell or to compare EMFs of two cells or to measure internal resistance of a cell. What is a potentiometer? It is a device which is used to measure EMF, compare EMFs, measure internal resistance. It is also called an ideal voltmeter. What is it? Ideal voltmeter. And what does it consist of? Just like the meter bridge, there is a wooden platform on which there is a very long wire. In meter bridge, you have a wire of 1 meter length. But this will have more than that one, like 10 meter or 20 meter. So long wire, a long wire, and that wire is made of manganese or constant N, and the two ends of the wire is connected to a battery, and that is a uniform wire. It is connected to a battery. Using this, you can make certain measurements. Fine, there will be a scale attached. Using that, you can measure. There is a balancing length, and there is a galvanometer. There is a null deflection. There is a balancing length. Everything just like meter bridge. Okay. Now, to understand this, you have to start from the uniform wire. We know for a uniform wire, resistance is directly proportional to the length. Okay. So, let me discuss these points further. Okay. Now, for a uniform wire, R equal to rho into L by A. R by L is called resistance per unit length, and that is given by rho by A. This is called resistance per unit length. What is the resistance between, like you have a wire here, I take a point, let me call this point as A and let me call this point as B, and the length of the wire between the point is LAB. What are A and B? A and B are the 2 points on the uniform wire. LAB is the length between those 2 points. Okay. What is RAB? What is RAB? RAB is the resistance of the wire between the points AB. How to find RAB? RAB is equal to length AB into resistance per unit length. Length AB into resistance per unit length, because we know resistance is resistance per unit length into L. So, RAB equal to LAB into R. Fine. So, if you take different points at different distances, the resistance will be different. Fine. Now, assume that you are connecting this wire to a cell. You are connecting this wire to a cell, a current will flow. A current will flow. A current will flow like this. Then here, this part has a resistance. So, there will be a voltage drop here. There will be a voltage drop. How much voltage will drop? What is voltage dropped between A and B? Potential drop between A and B. And that is nothing but current into resistance between A and B. Getting my point? Current into resistance between A and B, and that is nothing but I into RAB is nothing but LAB into R, where R is the resistance per unit length, and this can also be written like VAB equal to I into LAB into what is R actually? R is nothing but rho by A. Okay, this is the potential difference between A and B. Fine. So, this is how you work out on a uniform wire. So, if you have understood this much, I will just erase it and I will tell you some new concept. So, I will tell you again, uniform wire, R equal to rho into L by A, rho and A constant. So, that gives you rho by L, R by L, resistance per unit length. What will be the SI unit of resistance per unit length? That must be ohm per meter. And I told you, if you are given 2 points at a distance A and B, the resistance is proportional to length between them. I can get RAB equal to LAB into R. And if there is a current flowing, there will be a potential difference between A and B, and that will be equal to VAB equal to I into LAB into rho by A. Fine. Now, other than this equation in the box, I do not want any other things. This is very important to understand. Very, very important to understand. See, this is a uniform wire. Let us connect a battery here. Let us connect a battery here. Assume that its internal resistance is 0, R equal to 0. Internal resistance is 0, R internal is 0. Now, a current will flow. This current will produce potential difference between the wire. I am taking a point A here, another point B here, and I see that there is a potential difference VAB here, and the length is AB. Okay, and VAB is calculated as I into length AB into rho by L. Now watch out. Now watch out. What is VAB divided by LAB? What is VAB by LAB? The potential drop divided by the length. This is, you can get it from here. VAB by LAB is nothing but I into rho by A. This is called potential gradient. It is called what? Potential gradient. Just like a velocity gradient, we have potential gradient. And in NCERT textbook, they write this as phi. Phi, this is read as phi. Phi. Phi is potential gradient, that is potential drop per unit length. Phi. What is the definition of potential gradient? This is called potential gradient per unit length. What is SI unit? What will be SI unit? Voltage per meter. This will be volt per meter. SI unit is volt per meter, potential gradient. What is the equation of potential gradient? Current into resistivity by area of cross section. Current into resistivity by area of cross section. I rho by A. Fine. This part is not very important, but this part is important. VAB by LAB. Fine. Okay. Potential gradient is potential. This should have been potential difference. This is potential difference per unit length. The potential difference per unit length is called potential gradient. Potential gradient is potential difference per unit length. Please make a correction in your note. Fine. Now let us go a little more practically. This is all theory. This will go above your head. Let us do something very, very practical. Okay. Now consider a wire. Suppose this wire has got a length of 10 meter. 10 meter, and assume that you are connecting this to an EMF E equal to say 5 volt. 5 volt. This cell has got no internal resistance, and these are connecting wires, they have no resistance. So only these are connecting wires. These are connecting wires, no resistance. Cell has no resistance. Therefore, the potential, this potential 5 will appear here and this potential 0 will appear here. Right. So, what is the potential difference between one and the other end? This is your uniform wire. It's your uniform wire. So, what is potential gradient phi? How to find potential gradient by phi? You take the potential difference. What is potential difference? That is 5 minus 0 divided by length of the wire. What is the length of the wire? It is 10 meter. So, this is the potential. So, this will give you 5 by 10, which is 1 by 2 volt per meter. It is 1 by 2 volt per meter. What does that mean? That means if you take one point here and another point here at a separation of 1 meter, half volt per meter, that means 0.5 volt of difference in every meter. 0.5 volt difference in every meter. Then if you take 2 points here at a separation of 1 meter, then there will be a difference of 0.5 volt. Which will be at a higher potential, depends on the current direction. If current flows like this one, this will be at higher potential and this will be at lower potential. So, potential gradient from a simple circuit, the value, the calculation. Okay. Now, once you are thorough about that one, that's my water bottle, sorry for that. Okay. Now another point, say there is a wire, a uniform wire, and say that this wire has got a potential gradient of 2 volt per centimeter. 2 volt per centimeter, that is a potential gradient in the wire. How to produce potential gradient? That is by passing a current. Okay, if you pass a current, potential gradient will be created. And I am telling you that there is a potential difference of 2 volt per every centimeter. So, if I take a point here, another point here, with a separation of 4 centimeter, what will be the potential difference between this point A and this point J, A and J? I will ask you, what is VAJ? To answer this, you will go for the definition of potential gradient. What was potential gradient? Potential gradient was V between A and B by length between A and B. That is what we said. Suppose this is okay, V between. So, now what is the equation now? See, V, what is V between A and B? That is nothing but phi into length between A and B. But I am asking you, what is potential difference between A and J? Then you will tell me, sir, that should be equal to phi into length between A and J. That length is 4 centimeter. and the potential gradient is 2. So, this is 2 volt per centimeter multiplied by what is the length between that one, 4 centimeter. You can see that gives you 8 volt. That will be 8 volt. Potential gradient is given, you can find out potential difference. What will happen if this point is not taken here? Suppose this point is not taken there, is your wire. Instead of taking it 4 centimeter, suppose I am taking it at a different point here, so that this is 6 centimeter. What will be the potential difference? Naturally, there will be 6 into 2, it will become 12 volt. What will happen if I take it somewhere here at 3 centimeter? If I take J here at 3 centimeter instead of here, then that potential difference will become 3 into 2, 6 volt. So, it changes according to the distance. Okay. I think this part is also clear. Watch it till it is clear. Okay. I am still on this thing. Potentiometer has a principle. What is the principle of potentiometer? That is what I was telling. What is it? See, I am going to explain what is the principle of potentiometer. There is a wire, a uniform wire, and this is carrying a steady current I. Then every 2 points will have a potential difference. Like a point A and J, there is a potential difference between them, and that is given by Vaj equal to phi. What is phi? The potential gradient into Laj. So, we can say the potential difference between A and J is directly proportional to length between A and J. This is the principle of potentiometer, the working. If a uniform wire is carrying a steady current, the potential difference across any section of the wire is directly proportional to the length of that section. You take any section, the potential difference is proportional to length. This is the working principle. This statement is an equation here. What is potentiometer? It is a device to measure, compare EMFs and measure internal resistance. What is its working principle? This is the working principle. Tell me, in a uniform wire carrying a steady current, potential difference between any 2 points is directly proportional to the length between those 2 points. That is it. Okay. Now, we will calculate some potential gradient questions, which you see these questions are not directly asked anywhere, but this is important to understand. Fine. Okay. So, let us have 2-3 different situations. Okay. The first one, go for a thick line. First one, there is a uniform wire. Maybe in the second one also there is a uniform wire. These two are 2 uniform wires. Fine. Now, the first one is connected. This is connecting wire connected to a cell like this. The cell has got an EMF E. The wire has got a length L, okay, and the wire has got a resistance R. The internal resistance of the cell is 0, not considered. Okay. Call the wire as AB. Calculate potential gradient here. Calculate potential gradient in the wire. How to calculate potential gradient in the wire? Phi is calculated as potential difference between A and B divided by length between A and B. What is potential difference between A and B? No internal resistance, no drop. So, you will get this terminal voltage available here, E. Okay. Now, this wire is resistance-less. So, this point will have a potential E. Check that. And this point will have a potential 0. So, what is the difference in potential? Potential difference V between A and B is equal to E. That is E minus 0. E minus 0 divided by length is given as L. So, the potential gradient is simply E divided by L. Potential gradient is E by L in this case. Fine. That part is over. Understood. Now, this wire has got a length L, resistance is R2. I tell you why is it called R2, and there is a cell here with internal resistance R, and a series resistance R1. This is a wire AB, that is a wire AB. EMF of the cell is E and this is your cell. What is the potential gradient? First of all, calculate current in the wire. What is current in the wire? There is only one EMF source, but there are 3 resistors. So, what is the current? That is E divided by R internal plus R1 plus R2. E by R plus R1 plus R2. Okay. Now, what is potential difference between V A and B? There are 2 methods of calculating it. You can actually like find out drop in the internal, drop in here, E minus drop will give you that one. But there is a better way. What is it? Because you know there is a current flowing here and the wire has got a resistance R2. So, watch out carefully, that is nothing but I into R2. Okay. Substitute for I. So, this give you E into R2 by R plus R1 plus R2. This gives you potential difference between A and B. Now, potential gradient. What is the definition of potential gradient? That is potential difference AB by length AB. And potential difference AB is here. What is that? That is given by E into R2 by R plus R1 plus R2. This is VAB. Now, you divide it by length of the wire, divided by length L. This gives you the potential gradient phi. Last year, whoever said potentiometer was difficult, I asked them to study this, how to calculate potential gradient. Then they did it. They took only 5 minutes for that one. After that, the big problem simply vanished. Then everything became so simple. This is how you calculate potential gradient. Is it okay? Important, you memorize it, write it down. This is useful in the further discussions. Okay. Now, I can ask you so many questions on this. What will happen to the potential gradient if I increase EMF? If I increase EMF, what will happen to the potential gradient? If I increase EMF, phi will increase. Second one, what will happen if the resistance R1 is increased? If resistance R1 is increased, this is R2. If resistance R1 is increased, what will happen? If resistance R1 is increased, then the potential gradient, the denominator increases, potential gradient decreases. Okay. What will happen if the internal resistance decreases? If internal resistance decreases, what will happen? You can see that the potential gradient will increase. So many such questions can be asked, and say sometimes they will also ask about R2, but that is little complicated. We will discuss later during numericals, not now. Okay. So that part is okay. Potential gradient. Now what? Now something that can be funny. Something that can be funny. What is that? What is that? It's like this. If you have a uniform wire which is carrying a current I, and if I say there are 2 points, let us say call it as A and J, 2 points, then you should visualize that. You should visualize that. What? You should visualize that this A is at a higher potential than J. So there is a positive, there is a negative here. Is it visible? Or should I go for my? This should be there. You should see the wire like this. This is at higher potential, this is at lower potential, just like a cell. Just like a cell. That's important. Just like that means this wire, this section and this section is behaving like what? Behaving like a cell here. Here you should visualize a cell, and that cell will have its positive terminal here and negative terminal here. That wire is like this. This is point A, this is point J. And what is the voltage of the cell? And that is the potential difference, and that I can say that will be equal to phi into length AJ. That is the voltage between A and J. This should be there with your mind. Okay, practically this is important. Say there is a potential gradient of 2 volt per centimeter. Then if the length of the wire L between A and J, AJ, length AJ equal to 3 centimeter equal to 4 centimeter equal to 5 centimeter, what about potential difference VAJ? I told you this earlier, 3 into 2 6 volt, 4 into 2 8 volt, 5 into 2 10 volt. If you want to understand potentiometer, keep this in mind. When I explain, I will be using these values. Keep this in mind. Okay. Okay, fine. Now it's becoming more fun. Let us say there is a very huge tank like a reservoir, a dam, like a Mullaperiyar dam, a very big one with a large amount of water. Why I say so? Like if you take little water from this one, 10 liter or 100 liter or 1000 liter from this one, there will be no apparent change in the height. Height will remain pretty the same. Of course, there will be changes, but it will be negligibly small. Consider another small tank. This is a small tank. Okay. What will happen if you pour water into this one? If you pour water into this one, what will happen? If you pour water into this one, its height will increase. Its height will increase. If you connect these two, things with the pipe, what will happen? If you connect these two things with a pipe, what will happen? This level will not decrease, but this level will increase, and this can fill up to this same level. But once it becomes same level, what about the flow of water here? Then water flow stops. Water flow stops. Water flow is water current. Water flow is water current stops once it is at the same level. Okay. Once more. This time I have one water tank here, another water tank here, say almost the same capacity. There is water inside this, there is water inside this, this is connected by a pipe. This is A, this is B. Will water flow? If it flows, in which direction? There is water in this side, there is water, but I did not tell you about the height. So, what are the answers? I will say there are 3 answers, 1, 2, 3. Guess. It can go from A to B. It can go from B to A. It need not flow. There is no flow. These 3 possibilities are there. Why? Suppose this tank has got a higher level of water and this has got a lower level of water, then water will flow from A to B. Okay? Case number 1. Suppose this has got a lower level. Suppose this has got a lower level, this has got a higher level, then that will flow from B to A. Suppose they have both the same level, then there will be no flow. There are 3 possibilities. Fine. Why do I say so? I was talking about teaching current electricity, I am talking about fluid dynamics. Why? There is a very close relation, and we are going to learn that relation, and that is a heart of potentiometer. I will tell you what it is. Okay. Now assume that there is a cell here and there is another cell here. This cell is connected to a galvanometer and then connected to the cell like this. This is cell with EMF E1, this is cell with the EMF E2. Question, will the galvanometer show a deflection? A deflection is possible only when there is a current. Okay. Will it show a deflection? If yes, in which direction? Answer 1, 2, 3. See, I am giving you 1, 2, 3 just to tell you that there are 3 possibilities. Answer it. What are the possibilities? It can flow from E1 to E2 like this. In this diagram, it can go clockwise. I am sorry, anti-clockwise. Okay. If E1 is greater than E2, it can go counterclockwise. Counterclockwise current, and the galvanometer will show deflection to any one of the side. Okay. So, if E1 is greater than E2, galvanometer will deflect to any one side. Depends on the connection, left or right, only one side. Okay. Second one, if E1 is less than E2, E1 less than E2 means current will flow in the clockwise direction. For anti-clockwise direction, galvanometer show deflection to any one side. Then for this thing, GM will deflect to opposite direction. If that was to the left side, this will be to the right side. If that was to the right side, this will be to the opposite. Fine. Third condition, E1 is equal to E2, what will happen? That is what we want, the null deflection. That is what we want, the null deflection. Understood? Rewind and study. Rewind and study. But there is nothing to study in this. If E1 is greater than, that will flow. If E2 is greater than, then this will flow. If they are equal, there will be no flow. You don't have to worry about galvanometer. I can say that there is a bulb connected here. Will it light up? If there is a bulb connected, will it light up? In the last case, there will be no brightness at all. There will be no current. Fine. So that is also okay. Now I am modifying it. I am modifying it. See how I am going to modify this. You should remember that in a uniform wire carrying a current, any 2 point is like a cell. There is a cell here, but where and what is its value? You should know this. Now see this. Modification. There is a cell here. There is the cell here. Assume that its EMF is 6 volt. Its EMF is 6 volt. Okay. And these 2 points are connected here on the long wire. So I have the long wire here and I am connecting it between point A and J, and this carries a current in this direction. Now I told you, when you have a current carrying uniform wire AJ, then you know there is a difference of VAJ, and that is given by phi into LAJ. This should be there. This is what we are applying. Look here. 6 volt, it is positive, current going. For the section AJ, this is positive, this is negative. Consider that this has got a potential gradient of 2 volt per centimeter. I told you earlier that example. Assume that this distance is 4 centimeter. This distance, okay, one point, I will change this to, if you want to use that value, I will change this to 8 volt. I will change that to 8 volt, does not make any difference. Okay, 8 volt, and this is 4 centimeter. Okay, now I will put a galvanometer here. I will put a galvanometer here. Now you should realize that this is exactly like 2 cells. Which are those 2 cells? I tell you, there is an 8 volt cell out there, and this wire is behaving like a cell. And where should be the positive of the cell here? It should be on the side A and negative on the side J. So there is a cell here, And what is the voltage of the cell? Phi is given, length is given. How much is that? That will be equal to 8 volt. This is also equal to 8 volt, this is also equal to 8 volt. What will happen? No current will flow. Galvanometer will not show any reading. Manaslayo. What is the reading of the galvanometer in this case? 0. Why? If you are able to explain this, then you know potentiometer even before you studied it. Now see what will happen. What will happen if I connect this point here at 3 centimeter? What will happen? If I connect it at 3 centimeter, what will happen? Now you have only 3 centimeter here. 3 into 2, this will give you only 6 volt. So this will give you only 6 volt. What will happen? That is greater than this. Current will flow in one direction. What will happen if I disconnect this point? If I disconnect this point and if I connect this to 5 centimeter. If I connect that to 5 centimeter, then this will become 5 into 2, 10 volt. This is greater, current will show in the opposite direction. वो jockey याद है ना? वो jockey नहीं, physics jockey. If you have a jockey connected here, okay, jockey one wire connected here, and if I keep sliding here, if I keep sliding between 3, 4 and 5, what will happen to the galvanometer? 3, there is a deflection, 5, there is a deflection, but at 4, there is no deflection. If you keep sliding, there will be deflection. I am asking you again, if I move it at 3, then 2, if I move it closer to this point, what will happen? The deflection on one side will increase. And if I keep on moving to that side, what will happen? The deflection on the other side will increase. But this point of 4 centimeter, the deflection will be 0, it will stay at the center. This is the heart and soul of potentiometer. This is what you need to study. Rest is easy. So, bachcho, makkale, kulendegale. This is potentiometer theory, the basic thing that you need to understand. Today's class is very important, very important, very important. Next class, that's tomorrow, I will bring with the official version of potentiometer. Thank you so much for your time. See you in the next class.